Okay, so welcome to the sixth session. So today we are going to discuss something different from what actually is going on right now in the classroom. That is mostly there right now is focusing on the data structures, and after a few weeks they are going to talk about different types of algorithms, time complexity, dynamic programming, divide and conquer, and all that. That too using Java. So before we go to that aspect and you are going through that, maybe you're practicing the problem statements and everything, that's totally fine, but I want to give you something background information of the Java, the concept through which Java has been built, such that is it will help you in a broad knowledge when you write usually a Java programs, right? So let me share the screen now, and if anyone has to say anything, please put down the chat message in the Google Meet so that I can see. So allow me to share the screen. Okay, it's coming up, I guess. And you have to let me know whenever my voice is breaking or not, because right now it's raining heavily in Tirupati, so you have to let me know in time if my voice is breaking or if my voice is low or not. Okay, so let's start the session. So today, so in the previous few sessions we mostly did some live coding in terms of, so we have seen some programming patterns, we have seen stack queues over the period of time. So this I think this week the trees are going on right now in the NPTEL lectures, so that is I'm halting for the next week session because I thought something important that you should know about Java before jumping to trees. That you should obviously try it because for your competitive programming skills, increasing skills, but to get more deeper understanding of Java you should know few of the concepts. Okay, okay, so till now you have been introduced to generics, collections, array, stack, queues, linked list. Right now you're going through trees and heaps. All these things are there. That's quite good, and you should know it, how to code it through it. But when you go down after you got a job, and if you start working on, particularly working in a software project where you are going to use Java, at that point of time those structures might be useful, but you should know the structure of the whole Java itself, how it actually works in the background. So it is been working through basically 4 principles, so based on which it has been built upon. So can anyone type in the chat what are those basic principles on which the Java has been built upon? Any ideas? You can type down in chat, like any idea, like what are the main principles would be through which any programming language that you create will have some principle on which they built upon. Okay, so the question is, like, do you know any basic principles which Java uses in its background to such that what it is right now, why the classes exist, why objects are there? So they are built upon certain principles. So have you asked our question that what are those principles based on which it has been done? Okay, okay. So for Mohan, for this generic programming, the TAs of the course can only will post. Yes, Neeraj, yes, you are talking about 4 pillars. Yes, we are talking only exactly about the 4 pillars. Yeah, inheritance, polymorphism, abstraction, and encapsulation. Okay, so these 4 pillars are there which make up what's called object oriented programming principles, which you are going to use. Okay, my voice is low. Okay, fine, thank you. Now is it okay? Is my voice okay now? Is it for everyone? Okay. So for Mohan, I have to see a generic program question. I'm not allowed to see those questions. Maybe I'm not in this forum, so I have to see that. Okay, coming back to the this 4 pillars programming. So here what we are going to see is okay, we are going to discuss mostly inheritance, abstraction and polymorphism in this 1 hour as a background, which you are going to use it over the period of time when you start doing the software engineering. So it's just to give an overview of how it works in the Java. So some interesting fact we are going to see over the period of time. Encapsulation, very easy to understand, we will talk about it at the later end, because encapsulation is basically the one hierarchy level more above than inheritance and abstraction. Inheritance, abstraction, polymorphism. Okay, so the question first you should ask is, okay, we have some principle that on which we do, but why they are needed? So it comes down to this code readability and usability. So if I have to give very simple context, I want you to observe, go after this session, go and see you have written some program, and might be you have written that program 6 months back, and you don't know anything about that program. Are you going to able to understand very quickly, or you will take some time? There's a high chance that you will not even remember what you have written, why that particular logic is written. Even though you might write the comments also, still you find some confusion will be there. There will be no clarity of why the particular variables are used, why the particular functions are used. So for those instances, the structure, a particular structure of Java has been given. That is class, objects, function names, and all those. So that is one thing that is it helps on code reliability. Second is code reusability. You will come to a point where you will write a function, and that function has to be incorporate in different scenarios. For example, you create, suppose this Google Chrome or the Google Meet that you're seeing right now, the way it is written for even though they have same, everything is same, but the way it is written in the Chrome and way it is written in the Firefox might differ. A certain tweaks will be there, but the core functionalities will be same. So they don't want to write separate code for Firefox and separate code for Chrome. So for such kind of use, this thing, they say like, okay, most of the code should be reusable. Certain things we can adjust here and there to make the platform compatible. Okay, so coming down to us, we will go towards three. We will see the three principles mostly, and fourth principle will be at the end. To you will understand that why the fourth principle will come into picture. Okay, so when we say first is for code reusability, we will use inheritance. Okay, so the inheritance is a concept where you create a class, you have an objects and all that. That's totally fine. That's how the Java structure usually go on. But usually if you write multiple classes and you want to reuse certain code which is present in some other class, so how you can do it? So using inheritance, that mechanism is being provided. Okay, it comes through a is and a relationship that is called parent child. That is how you acquire certain properties from your parents. Similarly, when you write different classes, you try to acquire, in this case you try to acquire their data properties, that is the variables, instance variables, static variables, or you might try to have some functions out of it. So such kind of things were there, which you can achieve through inheritance. Okay, and obviously you can add your own, since you will have this, you can add more other functionalities in the child class as well to enhance it. But instead of you reusing it, writing the functions again, you're just based, because of this mechanism you can directly call that function and use it. So that is one thing. So few terminologies. Okay, terminologies which we are going to use for inheritance, that we are going to say. Okay, so before that there are some question. Okay, Mohan, for Mohan, can you stay after this session and then we can discuss? Okay, that fine. And for Neeraj, he's asking question: will it be better if we use class instead of object in the definition of inheritance? Okay, I will come back to you in this later. Why we are much focusing on the object rather than the class? Okay, I will come back to that thing, because you will get to know over the period of time. Class is just a blueprint. Everything is, at the end of the day, is an object. Okay, I will come back to you. So class is usually a blueprint or template that is you are defining, but at the end of the day, the compiler is only going to see the Java the objects. Okay. uh, Second is for child class you either call child class or subclass. For parent class you either call superclass or parent class. That is one thing. That is base. There's also called as base class and derived class as well. So many names are there for child and parent. And reusability, you're taking some functionals and functions and methods and fields from it directly from superclass, and you try to use it. Okay. There's certain rules that you should follow basically here. First is so you know mostly access modifiers are public, protected and private in this case. So they have certain classes that you should know. For example, in public, uh, if you put your class as everything as public, so any class which inherits from it you can access it. But if you put protected, they will add certain security values such that either it should be protected or public. They cannot be taken as a private. So that is another thing. And methods, if can declare private, even the inherited subclasses also they can't have it. Okay, so there are certain rules that you have to keep on, and you can try it out over the period of time. When you try coding there, you usually even programming, you usually use everything as public or static. But what about protect and private? If you do it, then you understand that what is the access, till what access you can use those methods and particularly variables. Okay, so there's something called super keyword. Okay, so why super keyword and this keyword? This is two important concepts that you should know in Java. So for example, if you have to see on the right side of the screen, so there's one class called superclass. There's a public class called subclass. Okay, so in superclass we have method called display and this variable called x. Similarly, in subclass also x and display is there. Now the question is, I will I will take some other method, maybe it's called my method. Okay, here if I just write display, so which function will be invoked? The function which is written in subclass, or the function which written in superclass? So just forget about this sub display and super display. If I just write display as it is, if I call you, I think it is still visible in my second device. So if you can try to see your internet connection once. So my question here is if I don't write sub or super here, I just write display. So at that point of time, which function will be get involved? Whether it will print subclass or whether it will print superclass? Can anyone reply that in the chat section? So my question is again, instead I will in this my method function I will just write display. I will just call it display. So what it should print it out exactly? Whether it should print subclass or superclass? Subclass. Exactly, correct. So but if I want to because why it is happening? Because there's a concept called method overriding which is happening right now. That is one thing which will we see in polymorphism. But another thing is, it looks at the local instances or local accesses. So first is always local, then only it will go for global. So to differentiate such instances, you can use super keyword. If you have two functions which are same with same name, same arguments and everything, and but you want a parent thing, at this point of time you can use super. Now another thing that here we can see is inside my method I have created another subclass object. Okay, suppose I don't have the subclass object, then how and if I write to display function, I have to tell specifically to the compiler that this is the display function is there, the subclass display function need to use. So I have to specify using this keyword. So this keyword will use that this keyword will use to tell the compiler that okay, this function, whatever the functions right now it's happening, it's taken from the subclass instead of the superclass. And for the superclass, if you want to have, you need to write super keyword dot the function name. Okay, same goes for the variables as well. If you write this dot x, or in this case sub dot x, it will take subclass value, and if you want to have superclass variables with the same names, you need to use super. So this is a convenience that you're having it over the period of time. Which function to call, which function not to call, which method, which variable to take, which variable not to take. Usually this is something which you may encounter a lot if you write a very big system. Okay. Another thing, there's something called as is a relationship and has a relationship. So what does it mean, is a relationship? When we say inheritance, it's a is a relationship. So when we say, okay, so here in the right top, we have defined a public class called animal, then it extended by another public class mammal, it extended by another public class called reptile, and it again extended to dog. So when we say when we are extending something, we always give a is a relationship for that. That means mammal is a subclass of animal, reptile is a subclass of animal, dog is a subclass of mammal. Okay, so the extend keywords will give that. That is one thing. Now has a relationship. You can argue here too with me that okay, I don't want to extend, I just want to use the function on the variable name. At that point of time, I just need to create an object of the class and then directly use it. So when I create an object without extending any class, at that point of time I will have a has a function. But again, the constraint of public protected private variable and function will come into picture. But I think that is quite clear with respect to has and relationship and is a. Is a usually used wherever you can see extend, you take it as a is a. Has a relationship mostly whenever you create an object without extending a class. Okay, question is by Harsh is, why do we need to use this keyword when it already use variable function of the subclass? Okay, so to answer this question, unfortunately I don't open my editor, but I will tell you this, to try to listen carefully here. In my method, okay, if I use int x equal to 10, right, in my method also I will write int x equal to 100, and then I try to print x. So what will the value will be the x? I want to know. So my question here is, I have in superclass and subclass, that is fine, but in my method also I will create another variable which is now named called int x equal to 100, and then I try to print x. At that point of time 100 will be printed, not 10. So for 10 I have to use this keyword. This keyword will specify that I'm mostly looking for the class variables, not the function variables. Class variables, function will have a different access, different length from where it can be seen, where it can't be seen, such kind of thing, right? So that's why this is much more useful to access the class variables. Okay, I hope this might be clear for you. Okay, now okay, now is a relationship. If I again to find is a relationship, mostly whenever you're extending a class, any class to another, it creates a is a relationship. So when we are saying mammal extends animal, that means mammal is an animal that we say. So but to better understanding or to get some idea, whenever you use the keyword called extend, this is we use during inheritance. At that point of time you consider it as is a relationship. But for has a relationship is simply like I have a class and I didn't extend anything. So in this has a relationship we have three classes, that is vehicle, speed and van. Van has been extended, van has extended the vehicle, but it doesn't have extended the speed. So but I need to use speed class as well. So at that time I will create an object and I will try to use that object to access any speed. That will become a has a relationship. Okay, so to access another class data without inheriting them is a has a relationship. Okay, now type of inheritance that we are going to see here. So there are multiple type of inheritance that we can see. To give an overview, this diagram would be sufficient. So in a single inheritance we will say that there is a subclass, this is superclass, and then subclass is inheriting for them. That is quite simple. Multi-level is I have a subclass 1 which is inheriting superclass, and this subclass 2 which is inheriting the subclass. So when we have multi-level, that is 2 level of inheritance here, so we can have 3 or 4 level inheritance as well. And then so in this case subclass 2 can also access the superclass variables and method also, considering it has some it will be a public. If it is a public variable, then it can access it. Might be it can also access the protected variables and methods as well, but I want you to try it out whether it will have it or not. Okay. Third is hierarchical. It's simple that multiple subclasses can access the one superclass. Okay. Multiple inheritance. Okay, so multiple inheritance was something interesting where we are saying that a subclass will try to inherit two superclasses, okay, or two or more superclasses. So this is an interesting case of multiple inheritance. Sometime it will work, sometime it will not work. We will discuss why it will not work. And there's a hybrid inheritance where it's a combination of hierarchical and multiple. Okay. So yes, Neeraj, what you're saying is correct. We will see the discussion. We will see why it can be done through interface, not through class. Okay, single inheritance. Just to give a simple example for that, we have created a class called animal, and we have to create a class called dog, and it extending the animal, that is inheriting the animal, and it is it has a function called eat. Animal has a function called eat, dog has a function called bark. And when you try to print it out in a class called test inheritance, you can have it there. You're creating a dog object. From dog object itself you can call the bark function also and eat function as well. So these two things directly you can do, because they are inherited to each other and they are not private. If they explicitly mention private, then you might not able to access the eat function. But right now, since you can access, you can also print the eat function, whatever the output of the eat function as well. So simple. This is simple single inheritance. Multiple inheritance, instead of apart from dog, we will have a baby dog as well as another class which extend the dog. So here I want to observe in the main function, that means we are creating a baby dog object here, and from that baby dog object we are trying to access not only bark function but also as a eat function as well. So it can access to one level higher class as well, which they're extending. So that's the beauty of Java, that you can, in spite of how many levels are there, so you can still use those functions. So that is multiple level inheritance that you might be using. You will use a lot when you are going to write codes in softwares, or if you have some assignment where you have to write long programs. Okay. Hierarchical is again, it's quite understandable that we have superclass called animal, and cat and dog is inheriting some feature called eat through the animal, and they're using it. Okay. So but okay, that being said, in this function we are also trying to use that, okay, even though we are accessing the animal, can we access the dog or not? But when you try it, see, that is, if you from the object of cat, if you try to access bark, it will not happen. It will give an error, because it is even though we're accessing the animal, I'm not going through a stop. I'm going directly accessing the animal methods and functions. So that is another thing that you should remember. Now, why multiple inheritance? As Neeraj said correctly, it can't be supported in Java, particularly for classes. But why? So to give an example for that, so we have class A, B, C. Now class A, B has same function called message. It might be have a different output, but it has the same function name. Okay, and since they are not related, so they are not overriding. It's perfectly. The problem comes when class C try to extend both the class A and B. Now if I create an object called obj of class C, and I try to call message, so the question would be, which message should be invoked? How should I say that? Here I can't use super because both are super. Here I can't use this. because I'm not calling from a B class or A class. I'm directly calling from another class which is just inheriting those properties and property methods and the variables. So how should we invoke? So that's the problem that Java find it in this. It doesn't want to give an ambiguity answer. So he said directly that if this such kind of instances arrive, I will give directly error. So this is a compile time error. So that's why you can't use multiple inheritance in Java. So if you can't use multiple inheritance, you can't even use hybrid inheritance also, where half part is basically multiple inheritance. But why it can be done in interface, we will see in upcoming slides. This, even though you can't use it as a class, but you can use it for interface as well. And what is interface, we will see. Okay, now so this is an overview of inheritance I want to see. Okay, so I will give you one fact, okay, that, and then try to deduce something out of it. Okay, so first, the fact is 80% of the classes or 80% of the whatever the code that is running behind the Java are inherited in some way or the other. That is 80% of the code, whatever in Java it's written, maybe through classes, objects, functions, whatever packages, multiple things would be, 80% are there. So the question is, do you think there will be any topmost superclass in Java? If it is there, why it's needed? That's another question, why it is needed. If not, why it should not be needed. Only one, I'm asking only one topmost superclass. So one has given the answer, but I want to ask why. Why do you think that only one superclass is needed, not multiple topmost superclasses needed? Any answer? Please type in the chat. Is some people saying yes, but I want to ask someone question as no also. But why do we need only one superclass? Why I can't have multiple superclasses? Okay. Any hints, any ideas from other students? They might be ambiguity, difficult to remember all. You're not going to remember everything. That doesn't have multiple inheritance. Okay, but what if I ever try to write my code in such a way that I don't have to use multiple inheritance? And it's not like there's only one superclass is there. There are hundreds of superclass will be there. But at the top of the root, there's only one superclass, which someone has named it as object. Ambiguity, no, because you will, in subclasses also there will be much subclasses, subclasses. Okay, the reason is this object. The word object itself is the main thing that we have to look at, not the class. The object as a word, the object as a meaning of the Java. When we say Java is all about object, all about some properties and variables, it has some meaning, and that's why they gave it even the root or mother of all classes, which they name as an object class. Okay, everything has to be defined. They started object as a root concept. It's not like they purposely use it. They can create multiple superclasses as well, but they choose that let's create a very abstract understanding of object from which everything is defined and everything is running in the Java. So they create an object class, and from that class they have hundreds or tens of class second level superclasses. From there you can, like for example, strings, arrays, all the data structures that you're going to use, collections that you're going to use, these all are superclasses in the back of the thing, and you're calling their functions by creating an object of it, whether you're writing system.in, system.out, or scanner class. All these are classes, and they all come under object class. Another thing is, whatever the class fact is on whatever the class you are going to use right now, in the background, just like constructors, it will be extending object class. You don't have to explicitly write that object class. Even without explicitly, the compiler will add any the object class, extending object class, like that. So if I say For example, in this test inheritance t, that is my public class, it would be my public class, and if I write extends object class, it will run. Even though you don't write, it will still run, because by default it will take that object class as a value, as inheriting value, because of object only, because of the rules that has been defined for object, it will take directly from this object class. That's how you can create it. Just like that you can't create, even though we can say that class is a blueprint and object is how, which is how representing it, how it is representing in the background in the code. So those things it is actually taking from object class. Okay, so this object class is actually a very variable from the thinking point of view, based on how they are seeing Java, also in practical point of view as well. Okay, we are left with 3 more topics, but we are going to cover 2 more, and third one is quite easy to understand. Okay, now something called as polymorphism. Now, before defining polymorphism, we have seen certain instances in this class where in inheritance that there's a high chance that 2 different classes might have same name, same functions. They might either by inheriting them or during the multiple scenario, mostly by inheritance. For dog also, the way he eat and the cat, the way they eat might differ. So they don't want, even though they have certain template from Superclass, they don't want it defined the same way how dog and cat eat. So they want some difference. So that kind of things, Java allows them to define the eat function separately for dog and cat as well. But the question here again will be that how the compiler will understand that if I have same name, same parameter again and again, so it even though you add super and this, so this there will be certain methods, certain ways through which the compiler should understand that okay, the child class is trying to develop its own function, though it is inheriting from the superclass. In this concept, polymorphism come into picture. So they are actually related. So from inheritance, polymorphism concept derived. You can say polymorphism is derived. That means one task can be performed in different ways. That is, eating the way human eats, the way cat eat, the way dogs eat might be different. And for all those things, if there's a way I can define it, I will try to define it, rather than directly saying that how mammals eat. Okay, so in this 2 type of concept will come method overloading and overriding. There is something called compile time, and this which is called method overloading, and there's something called run time, that is method overriding. We will say these 2 examples, and for those who doesn't know what is compile time, what is run time. Compile time is when you try to debug the program the first instance by compiler. It is still not yet in the memory, but you try to compile it to see whether it has some syntactical error or logical error or not. That time it's called compile time. Runtime is when the program is actually running. At that, during runtime only, it will identify that what kind of polymorphism is actually happening in the background. Okay, so first is method overloading. It's quite easy to understand method overloading. That means I may have multiple classes, or even the same class I may create 2 multiple functions, and each even though they have same name, but they might have different arguments, different number of arguments, or they might have different data types. So right now in this example I've shown you only for in a single class, but you can have it for multiple classes as well, where you're extending certain classes. So here in add function, you have 2 variables in separate add int abc. So there's a third another function with same name but different number of arguments. It will override. So based on the parameters here, it is able to differentiate. That's how the method overloading is happening, and that's how it will understand that during the compile time. Same for changing data type of arguments. So instead of having int add and 2 arguments, I will create double add, because the function name is same, but the data types of double int has been changed to double. So based on the parameters, again it is changing. So it's more about the parameters, how you're calling the parameters. even if you see the constructors, there's something called as default constructor, there's something called as parameterized constructor. So the constructor name is same as class, but the way you're giving the values parameters, it gives a different definition to the functions. Okay. The sequence of parameters is obviously it's a very important thing that you have to consider. Okay, how we can understand static and dynamic binding, what exactly it is. Okay, so static. Okay, to give you a very overview picture, for that you should have little bit understanding of the compiler course. Okay, but to give a very high overview, when binding comes into picture, it is mostly how the variables, how the functions are related to each other, and the relationship is usually identified before running the code in the memory. That means I already know that I have n amount of variables. It may be int, some may be char, some may be arrays, all of this, and I have some certain functions as well. So this information I will know, and I will try to keep it together in such a way that it runs smoothly in the memory. But for the dynamic thing, what usually happens is I will write a code which compile time can't understand, maybe because of the logical in the way I wrote the logic, and it has to form the relationship between multiple functions only during the runtime. Okay, that is dynamic. So during runtime, compiler can't understand the how the variables are connected during because of certain logic. The way you write like recursion, even though they write compiler can find all the syntax and everything in the compile time, but it doesn't know the concept of recursion unless and until it runs unless and until you run it in the actual memory. So that kind of dynamic or late binding will come into picture. Okay, the compiler ignores the implementation. Yes, you can say like that it might ignore the implement. It's not actually ignoring the implementation. It's something like the compiler doesn't have that much intelligence to understand what exactly the logic you have written. He can't understand all the time. He has some checks and balances to see the syntactical errors, and whether it's combining the rules of the grammar that it's following. But the way you write the logic, it's actually during runtime only you can understand. Okay, so this is method overloading. That means the name of the function will be same, but the parameters might be differ. Maybe the what you say, the changing the type of arguments, or the way the arguments has been called, different sequence of arguments. All these things come into picture. Now, an interesting thing is method overriding, which you can usually find during runtime only. So what do you mean by method overriding? Let's go back to one of the examples here in okay, here. So for method overriding, we were discussing that the display function is there in superclass, the display function is in subclass as well, but how to differentiate about it if we don't add super or this and all that, right? So when compiler when the compiler of Java compiler will try to see all the relationship between the different functions and variables, it usually checks only the function call, and it doesn't actually see that from which function it has to take. It knows that the display function is there in both superclass subclass, but doesn't know from which it is taking. At that point of time, when the program is actually running, during that time it will override based on the keywords of super or this. So these keywords actually help during the runtime, and it will override the display functions. So for example, if I don't use super and sub, and I just call display function, it will usually take the display function from a subclass, because I am creating a subclass object. That is a method overriding that is I am doing. The compilers can't identify this. It can be identified only during the runtime. Okay, so that is the concept of overriding. That is, if subclass has the same method as declaring parent class, then mostly the child class method will be running rather than the parent subclass, unless and until you write specifically super keyword there. okay, or you don't have the same class as well. That is another thing. So it is usually you can define during only runtime when the program is actually running. Okay, so if there's some rules of method overriding is it should have a same name and same parameters, and it should be and it should extend this there should be is a relationship, that is that subclass, there will be something considered subclass and superclass, then only method overriding will come into picture. Otherwise, if you two classes have same functions, at that point of time also you can create an object and the object will become as a differentiator because they are not inheriting with each other. Okay, so to give an example, here is we have animal and dog. So the dog is extending from animal and both have move function. Okay, so in move function of animal can move, and in dog's move function it is dogs can walk and run. Okay, so if I try, so in the main function we have animal a new animal, that is I'm creating an animal object, and from that if I'm calling a dot move, it will show it will directly show that move function of animal. That's just that will be quite clear. The interesting part here will be the b, the object b here, that is animal b new dog. So actually what happening here is, while compiling, the compiler will think that the b is an object of animal. Okay, but when it's running, it will see that which function it is calling. So it's calling the dog function. So that when you say called dog function, it basically it's calling the constructor dog constructor. So actually, even though it has an animal reference, at the end of the day it will be act as a dog object. So when it says b dot move, then it will run as a dog class rather than an animal class. Okay, so this is something I want to focus. Animal b is equal to new dog. This is a very interesting concept that you can use in your programming, and it will give a very secure code in terms of the people, because even though compile timing will think that it is an object of something else, but turns out that whatever the class name that you are assigning at the end from which the constructor will be done, it will create an object of that class. But the condition should be that the dog should be inherited to animal. If the dog is not inherited to animal, you can't do it. This will give an compile time error. Okay, so this is another thing. Another example of Java method overriding here is okay, this is for method overriding. So if you just look at this diagram, I have something called bank, and it has one function called rate of interest, and for the all and we have 3 different banks called SBI, CCI, and Axis. They are extending it, and they are extending those functions, but the way the interest return they provide is different. So it gives them Java, without even reusing anything much, without typing it much, it is just extending and then just returning the value based on the specific bank rates. This is one thing which it is using the concept of both inheritance and polymorphism together. And you will find when you start looking more on Java code, you will find that all the 4 concepts are present in the single it will be available in the single file as well. Okay, so now the third concept is there, that is abstraction. Okay, now in literal term, abstraction is I will give you an information that okay, this is a functionality, but I will not tell you how it will work. So for example, you are watching this through Google Meet. Okay, you know that this is used for video calls and lectures and for face-to-face interaction, online interaction, right? But you don't know how it is working because you don't need to. If you're riding a car, you should know that how to change the gear and how to steer the wheel. You don't know that how the steering of the wheel is actually making the car move, or how changing the gear will help you the car move. So that's the concept of abstraction that we use a lot in our real world, that we try to implement in Java as well, because Java is trying to mimic the real world settings as well. Okay, now this can be achieved using two things, which is called abstract class and interface. Now the abstract class can achieve abstraction 0 to 100%, but interface is proper 100% abstraction. So what do we mean by that? We will see in the next few slides. Okay, so first is interface. It's very straightforward in this interface. Now we say object class is a object blueprint of the object, but interface we will say a blueprint of a class. So what does it mean? That in interface I can declare only I can declare only the classes. I can declare only constant methods. I cannot define them, and I cannot initialize them. I can initialize only the constants. I can't create an instance variable whose values will be changing. Okay, so that's the 100% abstraction I'm giving. I'm just giving a template without giving any information there, without giving any logic, that to present as an interface. Okay, and it also gives a easier relationship. We will see how. So like we have said, the car, like you just have to steer the steering wheel without knowing how the car is moving. Okay, that's the abstraction that the car manufacturer has given to you. So what I will do is I will create but the same thing is there for all the cars in this world. Okay, it's not like that I will use some other mechanism to move the car. It's not like that. Every car has a steering wheel, every car has a certain kind of gear system, brake systems and all that. So that blueprint is same. So if you want to actually try to present in the terms of interface, in terms of Java coding, so you will say you create an interface. So what you have to do, you will just give certain functions. That is, we have steer, it can accelerate, it can brake, clutch, shift gear, all those stuff. But the interesting part here is, even though I have an interface, I am not implementing anything there. I have to implement based on the manufacturers. So the way Mahindra will manufacture a car and the way the Tesla manufacturer is totally different, though they have all the same features. Okay, so Tesla might put steering wheel on the left instead of right. Okay, but Mahindra used the right system. So implementation I can do multiple things, but to give us overall idea, I'm to give abstract that okay, this minimum things should be present in a particular car. I'm defining them using interface without and how should I implement it, that is left to manufacturers or the programmers to programmers. Okay, yeah. So abstract methods we will come to in picture. What is abstract method as well? So mostly these functions or abstract methods, when you say this, if you look at it here, we didn't use the abstract keyword, but it's public. All these functions which is not defined are public in nature. You can't put it in private. That's a strict no, because you want to use this interface for multiple implementation, that it has to be public. So that is one thing that you should quite remember for this. Even for the variables, the constant you're going to use, for that as well, you have to keep it public or static. Okay, so to give a simple example of what can we do is, we have an interface called drawable. From drawable we can drawable is the interface, and from the interface we want to create certain shapes out of it, be it rectangle, circle, triangle, anything. So what I have to do is to inherit and drawable has a certain function which is called draw. So this draw is so what I have to do is, I know that I have to, for rectangle I have to draw, circle I have to draw. The way it has been it has drawn might be different. So here I just printed out system as drawing rectangle, drawing circle, but if you have to logically program, typically you have to think at that point of time, you have to give breadth and length, or you have to give the diameter of the circle, then only you can draw actually. So I have just given a blueprint or template which as a function which I have to use in my own class, and to use an interface I have to use a keyword called implement. To inherit a class you have to use extend. For inheriting an interface I'm using implement. Okay, that is another thing that I want you to remember during this thing. Okay, so it's like this. I have given you a canvas and I have given you color. That's the interface I'm giving you. from that colors and the particular page you can draw anything. So that is a best example of how the interface should work up. Okay, another thing is, okay, there are certain rules that we should know for interfaces. You can't create an object for interface. You don't have any constructors because you don't have any object. That's why you don't have any constructors for that. All the methods in interface are abstract. That means I didn't give any what you say definitions in the interface. I just declared it as void row. I just declared it. Okay. The interface cannot have instance field. When you say instance, that means the values of that field may be changing, but we don't want that. It in interface it should be static and final. That is, if you're using pi value, the pi value has to be final. You can't change the value of pi. Okay. It is usually not extended by class. It is implemented by the class. The word implements gives that idea of when we say implemented. Okay. And it can support multiple inheritance as well. The reason why you can support multiple inheritance is quite is because you didn't define anything in the interface. Okay, we will see that as well why it is not there. Okay, now the second concept is in this abstraction is abstract class. It is same as class, but it can have abstract methods, that is methods without any definitions. It can have normal methods as well. It can have instance variables. It can have, so it's a combination of normal class and interface. It's a conjunction of both those concepts, and they made an abstract class here. Okay, but here you should explicitly say that it's an abstract class. So if you have an abstract class, you must have a method which is called abstract. The abstract keyword should be used in both the class and both the method as well. Okay, so for example, an abstract class is called bike, and it has a function abstract method called run. So if I create a class called Honda bike, something like that, and extend a bike, I can define the run function, and I can create an object for that. I can run. I can't directly create an object for abstract class, but I can create indirectly. That is here bike obj new Honda. So that is one thing. Another that you have to keep in mind while doing it. You're extending abstract class, but you're not defining much there. So another thing, another interesting thing that we can see here is the combination of both interface and abstract class. So in interface we have 4 functions A, B, C, D. In abstract class can implement an interface. That is one thing. Because not every function has to be abstract. In abstract class, at least one function should be abstract class. I say abstract method. That is the condition. So for public C, public void, I can create IMC. Similarly, for a class M, I create a class M which extending the abstract class B. So that means it can inherit indirectly through indirect ways. It can also access in interface A as well. That's why you can access ABD as well. So whatever you choose have access in abstract class B, and whatever it implements as an interface or extending the same concept will apply in class M as well. Consider it as a combination of multiple inheritance. So here multiple inheritance is also coming into picture, even though you have an interface as well. Okay, and then using another public class, you can try to create you can call certain objects. Okay, so these are certain. Okay, so interfaces are quite restrictive in nature because they don't want to provide too much functionalities. They just want an abstract class and static fields and the final fields, non-final fields. Say final fields. Okay, that final is basically constants. So when do you use abstract and interface? To give an example for that, okay, the similarity between a bird and plane is that they can fly. Okay, so if you want to implement bird and plane, instead of keeping us a common property of flying, you can create an interface of flight which can and there you can define some function which gives certain differentiators between bird and plane. Okay, on top of it, if you want something extra as well, that for example asset, plane can be an asset. So you can have that as well, and it can have same functions, but since you are not defining anything in those functions, those interfaces, any function that put in interface, you can't you can't define anything, so you have to define in the same class. So that gives a proper understanding of it removes the ambiguity. So because it removes the ambiguity, the compiler can run it properly. The question is why constructor M is calling here while we are creating class A object. Okay, so if I have to explain it again here, what is actually happening, in public static void main, there is a object called A. It is referenced as interface A. Remember that A cannot have a object, but compiler considering that it is object of A, but when actually it started for runtime, it found that it's not an object of interface, it is actually an object of M, which is a class. Okay, so it's a dynamic reference that you're giving to the object. So it's actually not it's not an interface object, it's actually a object of class M. Okay, so that is that. For the example of burden plane, we can use multiple inheritance because you're not defining anything in the interface. You have to define in a particular class wherever you are implementing them. So it removes the concept of ambiguity there. Okay, another thing when you have to use abstract classes, where certain kind of even though you can use the same concept, some common functionalities in abstract class as well, but somewhere you have to be concrete, somewhere you have to be quite abstract in nature. For example, eat, sleep and drink will be differ for different kind of might differ for the particular based on the classes that you are having. Okay, it creates a different hierarchies. So to combine everything into one single place, at the same time you want certain extra functionalities, you use abstract class. Okay, but you just need a template without doing anything much about it, without defining anything. You use an interface. Okay, abstract will give you more better options, interface give you more restrictive options. So you should identify that when you're creating a software, which options you need, more restrictive one or more flexible one, and both are needed at certain point of time. Okay, so that's a basic overview of abstraction as well. So if I have to summarize, the third concept comes encapsulation. So if I have to summarize here, it can be summarized using this program itself. Encapsulation is combining every object, every method and every variable into a particular to encapsulate or to restrict to into one entity, which we call object. So here when we create a class of M, object of M, it is not only it is inheriting or implementing the property of abstract class B and interface as well. That is encapsulated multiple instances of multiple principles into one single object. That is, the A object can also access interface A, and it can also access abstract class B as well. So that's the beautiful concept of encapsulation. You're binding everything together in a single bundle. Okay, so that's the understanding of encapsulation. You join every concept and you try to make a single program. So okay, so that's the idea for that's a basic pillars or idea for this Java that we are going to have it. Now why we are having why this discussion have it, because in the next session we are going to discuss something about trees, and if you have attended the earlier sessions as well, in those scenarios also we have created the functions, so we have created method for stack and queues also in different ways, and those different ways are quite much needed to understand that different ways to write a program. And if you don't know the concept of these, that why we are extending, why we are creating an interface, or why there's a need of open-ended why there's a need of um, objects inheriting from some other class. uh, if you don't understand the principle behind it, you may not appreciate why it is written in certain way, because Java is usually considered as a very typing exhaustive language. That means we have to write a lot compared to Python and C. But there's a reason for that, because they have given a proper structure which they follow, which give them very secure give them very secure environment for the code and to maintain them a lot and so on. Okay, so that's the end of the session for this week. Next week we are going to discuss trees, mostly if time permits heap as well, but mostly we'll test the tree. We will do some live coding there. We'll try to write different operation of the trees. Okay, so I'm stopping the recording now.